Hello everyone, welcome back to the channel. This is the last topic for arithmetic, speed and distance. Before this, we did time and work, and also there was a video on previous year questions. I would suggest you watch that video, interesting topic, and very likely the question could come in the exam from that topic. Today is speed and distance. In the number of questions that could come in the exam, even more than time and work or any topic in this arithmetic. So please pay attention. After I can percentages, no other topic has more questions than speed and distance. That has been asked in last 10 years. Right? Now let's start with the concepts of speed and distance. First thing, what time is, what distance is, and after that we will understand what speed is. So what is time? Suppose there are two cities, say Delhi and Mumbai. So I hope you have heard about Delhi Mumbai Expressway. So they so Mr. Nitin Gadkari, he's always saying that time taken for you to go from Delhi to Mumbai will be cut in half. Means earlier it used to take 24 hours going from Delhi to Mumbai. Now it will take 12 hours. So I hope you understand what time is. Time is just a time taken for you to go from one place to another, or time taken by you between point A and point B. What is distance? Distance is the space or spatial distance between two places. Now, space between Delhi and Mumbai, suppose it's 1800 kilometers. So, that is the distance between two points A and B. Time and distance, I hope this is clear. Now, what is speed? See, suppose Delhi and Mumbai has not moved. I am hoping that the roads are the same. Roads going from A to B are the same. Earlier, it used to take 24 hours. 24 hours. Now, due to expressway, you you can do it and cover it in 12 hours. So, what is the speed? What was the speed of, of your car when earlier and now? So, the formula for speed is distance divided by time. Means total distance you are covering divided by time. So, distance earlier that has not changed. Suppose that is 1800 divided by 24. I hope this is clear. So, solving this 12 to the 24, 12 50, so 75. So earlier you could drive for 75 kilometers per hour. I hope this calculation is right. Yes, the calculation is, I hope that is correct, right? Now, the same distance can be covered in 1800 kilometers. What will be the speed of your car now? Distance upon time, 12, 12, 6, 150 kilometer per hour. I hope this is clear. So now, what is happening? Is why has the speed of car increased? The speed has increased. Why? Because we have better roads, less traffic jams, less turns, less brakes. So you can drive your cars even faster to cover the same amount of distance. So I hope the concept of distance, time, and speed is correct. So distance is the spatial distance between two points. Time is the time taken going from A to B, and speed is distance divided by time. That is represented in what form? What form? Kilometers per hour, kilometers per hour, or meter per second. These are the most famous one, meter per second and kilometers per hour. Whatever you see in your car, that is in kilometer per hour, 80 kilometer per hour, 90 kilometer per hour. But meter per second, this we can also code them in the meter per second when it is useful. In many cases, suppose we have to calculate the speed of Usain Bolt when he's covering a track of, say, he covers a track of 100 meters. So Usain Bolt is covering 100 meters in, say, 9 seconds. What was his speed? You will do it like 100 distance upon 9. You will get 11, I guess that is 11.1 meter per second, right? So this is the speed in meter per second. Now the one thing is, many times they will give you distance in meters, then speed time in hours, and speed in kilometer per hour. So the values could change. You should know how to convert kilometer per hour to meter per second and vice versa, right? To convert kilometer per hour, suppose 1 kilometer per hour, r will go in the denominator. To convert into meter per second, how to convert kilometer into meters? Kilometer is 1000 meters. And how in 1 hour, how many seconds are there? 3600. So second. To convert kilometer per hour into meter per second, you have to multiply it by 5 by 18, right? Multiply kilometer per hour by 5 by 18, you will get meter per second. I hope I am doing right. 2 5 uh, 2 5s are 10 and 2 18s are 36. So 5 by 10 multiplying kilometer by hour by 5 by 18 will give you meter per second. But if meter per second is given to you, suppose they have given to you 1 meter per second and they have asked you to convert into kilometer per hour. So 1 meter is how many kilometers are there? If we say 1 meter has 1 by 1000 kilometers and 1 second has 1 by 3600 hours, right? This is just a logic that 1 kilometer has 1000 meters. So 1 meter has 1 by 1000 kilometers. So going by that logic, and you will get 18 by 5. So to go from meter per second to kilometer per hour, you need to multiply it by 18 by 5. Going from kilometer per hour to meter per second, you have to do what? You have to do into 5 by 8. I hope this is clear. Very easy. Kilometer per hour to meter per second. Multiply it by 5 by 18. Meter per second given to you. You can convert it to kilometer per hour by 18 by 5. Now moving on. Average speed. This is what we have already learned in the averages video. Average speed is not distance upon time or v1 plus v2 by 2. The formula for average speed is total distance upon total time. I'm not going to spend a lot of time on it, but simple thing is you have to all the distances are added in the numerator and all the time is added in the denominator, and that is going to give you the average speed. Now, if S1 is the distance in time and covered in T1, so what will be the total distance covered in T1? S1 and T1. So this is S2 and T2. So what is the total distance? S1 plus S2 plus S3 and so on. Total distance upon total time is T1 plus T2 plus T3, so on. More on this have been covered in averages video. I'm repeating. You can go there and find a lot of different cases we have covered. How to calculate average speed when velocity is same and all those things. So just remember this formula. If you have to calculate average speed, you should have to add all the distances in the numerator and all the time taken in the denominator. This one is done. I am not devoting a lot of time because already covered. Moving on, relative speed. Very interesting topic, and good good chances question could come from here. Otherwise, this topic will be used in the boats and stream questions as well, boats and river question, which we'll see in future slides. So that is why very important. Please pay attention to this. The concept is simple if you understand this once, right? Suppose two cars are going in the same direction. I hope you have driven on a highway. So you are going at a speed of say 50 kilometers per hour, and there's a car in front of you 80 kilometers per hour going at a speed of 80 kilometers per hour. So this is a road. This is you are sitting in this car. What will you see? Since 50 kilometers per hour speed is not sufficient for you to overtake this 80 kilometer per hour. So what will happen? This car will keep going and the distance will keep increasing, right? So what is happening? With 50 kilometers per hour speed, you will not be able to overtake 80 kilometers per hour speed. Second case, now you have increased your speed to 80 kilometers per hour. Now your speed is 80 kilometers per hour, and the car in front of you is going at the same speed of 80 kilometers per hour. Your distance will stay the same. This you will be this the distance of separation will stay the same. You both will be going in the same direction at the same speed. So you will the separation between you two is not going to change. So in the 80 kilometers per hour, you will not overtake the car in front of you, but the distance between you two will stay the same. But after this, what you have decided? I am going to overtake this car. To overtake the car, you have to increase your speed more than 80 kilometers per hour. Suppose I say it, I make it at 120 kilometers per hour. So 120 kilometers per hour speed is now my speed is 120 kilometers per hour, I will be able to overtake the car in front of me. I hope three cases are clear. When it was less than 80, I will not be able to overtake, and the gap will keep increasing. When I was 80, I will still not be able to overtake, but the gap will remain the same. But when my speed is more than 80, I should be able to overtake it. Just that it depends on how much time it will take, right? Now, what is happening in case of 120 kilometers per hour? Suppose I am assuming that both the cars are going at 120, 180 kilometers. Suppose I assume this car is not moving at all. It stops altogether. So the relative speed is the speed of my car, assuming other car is at stop. Assuming car is still moving at 80 kilometers per hour, my car is still going at 120 kilometers per hour, but my relative speed with respect to other car is speed of my car, assuming other car is not in motion or at stop. So if two cars are going in the same direction, to calculate relative speed, if two cars are going in the same direction, then always remember minus. What minus? You will see. If the other cars we have assumed of going at speed of 80 kilometers per hour and it says stop, the relative speed of my car will be 120 minus 80 minus 80. So that is 40 kilometers per hour. This is like earlier we were going at 120 and 80. After that, I am going at 110. He is going at 70. After that, so suppose that car has immediately stopped. Immediately stopped. So my relative speed with respect to that car is 40 kilometers per hour. How it is useful in solving the questions, I will show you. Suppose, let's say, I will give an example. Two cars, two cars are going bit from A to B, and there's one car here, your car, and there's another car here, second car, right? This is going at a speed of 80 kilometers per hour, and this is going at a speed of 120 kilometers per hour. Now, they ask you that the distance between you two cars is suppose 100 meter, 100, no, not 100 kilometers, let's say it's 10 kilometers. So, two cars at a distance of 10 kilometers, and you are going at 120 kilometers, and that car is 80 kilometers, right? Now, they will ask you at what time you will overtake the other car. First thing is you could do, you assume that it keeps moving for some time. You assume it keeps moving for some time. Then what will you do? The distance traveled by car in front of me minus distance traveled by car by me should be equal to 10. Long process. Or what I can do, I assume this car is at halt or is not moving. So my relative speed will be 120 minus 80, that is 40 kilometers per hour. So time taken by me to cover the gap of 10 distance divided by, so our formula was speed was equal to distance upon time. So to calculate time is distance upon speed. Okay, so time taken for me to cover that 10-kilometer gap, but my speed is relative. Why relative? Because I am assuming that a car in front of me is not moving. So 1 by 40 kilometers per hour. So you will get 1 by 4 hours or 15 minutes. So it will take me 15 minutes to overtake this car. I hope this is clear. This is where the relative velocity concepts will help you. Now, second thing, two cars are going at a same direction. Distance between them is 100 km per hour. This is the speed of car A and car B, right? Now you need to overtake. Which car will be in the behind? So there are two cars. So if this is 30 kilometers and this is 70, this 30 kilometers car can never overtake for a 70-kilometer car. So that is why the car in the back has to go at a higher speed, faster speed, and that speed will be 70 kilometer per hour is this car, 30 kilometer per hour is this car, and the gap between them is 100 kilometer. Solve time taken by car behind car to overtake car A. I hope this is clear, the concept of relative speed. Now moving on. If two cars are going in the opposite direction, suppose this car is going at 70 kilometer per hour and this car is coming towards you at 120 kilometer per hour. They both are coming towards each other. Now, have you seen this thing? That suppose you're sitting in a train and there's another train coming towards your side. You will see that the speed of train, relative speed will look very high because both trains are coming towards each other, right? But if you are going in the same direction, you will see the other train is constant at a same pace as you, same speed as you. But if something is coming in front of you, right, you will see that even his speed will look very high. Why? Relativity. Why? Suppose two cars are going in the opposite direction. Again, I will say that there is a distance of, suppose there is a distance of 30 kilometers between them. Now, after how long the accident will happen? The accident will happen when they will meet. After how long the accident will happen? The accident will happen after time. Time is equal to distance upon relative speed. So now relative speed in case when going in the opposite direction is plus. Remember plus. Plus is why? Because I what is relative? I assume this has train has stopped. Now my relative velocity will be, the relative velocity will be 120 plus 70, that is 190 kilometers per hour. So if the other train is at stop, my speed will be 120 plus 70, that is 190. So 30 by 190 kilometers per hour is the time taken for the accident to happen. I hope this is clear. This will get even more clear when we'll do previous year question. You just have to know when to use a minus sign and when to use a plus sign. And this is a question homework for you. You can do it on your own. At what time the collision will happen, right? Now moving on. Boats and stream question. So boats and stream question, what is happening? See, this is a boat. Boat can go, because of the motor in the boat, it can go at a speed of, say, it can go at a speed of 40 kilometer per hour. Why? Because of the motor in the boat, right? There's a fin at the back and all, because and there's a sail. Because of itself, it can go at a speed of 40 kilometers per hour. But if you have done swimming in the river, I hope you know that on the direction of the river, people can easily swim. Why? Because they are going with the flow of the river. That is what they say, going with the flow. Water is taking it with you. But if you have to go in the opposite direction of the river, it's very hard. Why? Because there is a speed of river which is obstructing you, which is causing a problem for you. But when you're going the same direction as a stream, that that river is helping you to go in that direction, right? So 40 kilometer per hour is the speed of the boat in the still water. Means this is the speed of the boat which boat can attain in the normal water. There is a stream. Stream means river. So if downstream means this is river going in this direction, right? Now there's a boat here. There's a boat here with the speed of 40 kilometers on it on. This stream will help it to go in this direction. But when boat will go in the other direction, that is known as upstream. This is downstream. This is upstream. Upstream means going against the river. So when the boat will go in the upstream direction, the river will create problems. It will slow the boat. So in downstream, the speed of the boat in still water and speed of the river get added. So this is B. Boat and river get added and boat will move in even at a faster pace. But when it is going upstream against the flow of the current, the boat minus velocity of the river will be the actual speed of the boat by which it is going. This is again the concept of relative velocity, where in downstream boat water is helping the boat to go with it. In upstream, water is water is against the speed of the boat. So that is why the speed of the boat is speed of the boat minus the speed of the river. This concept, I hope it is clear. We are going to use this concept when we'll see previous year question from this. but you have to know what speed of stream is, what speed of boat is, and this is very important, that in downstream the boat speed is VB plus VR, means its own speed plus the speed of the river, but upstream is VB minus VR. Now there's a question. A boat can go downstream at 12 kilometers per hour and upstream is 8 kilometers per hour. Again, I've told you VB is the speed of the boat and VR is the speed of the river. When it is going downstream, the speed of the boat and the river will help each other and it will increase. So this is 12 VB minus VR. When it is going upstream, this is 8 kilometer per hour. You can calculate simple VB minus VR. 2 VB is 20. So VB is 10 kilometers per hour. What is VB? VB is the speed of the boat in still water. To calculate VR, you can also calculate VR. That will come out to be 2 kilometers per hour, and that is the speed of the stream. I hope the concept of boat and stream is clear. This will be even more, you will find the concepts clarity even more when we will do the previous year questions. Moving on, a circular motion. I hope you have seen the track and field game in your schools, that there is a track like this or in the Olympics, right? So so all the racers starts from here, they run the whole track and they come back and this end point, something like this. So we are going to learn similar thing, but in a circular motion. In a circular motion, some people, so in the circular motion, a race will happen. A and B will start running. So they will run, complete the track. That is lap number 1. Then they can go back and do lap number 2 and 3 and so on. So a circular motion is happening. Or this is another case as well. When A is going in this direction and B is also going in this direction, but C is running on the other side. So A will be going from this side, C will going from this side, B is also going from this side. So this is a circular motion, and the questions on this have also been asked. So we'll see few concepts on this as well. Right? Let's start. When two moves in opposite direction, their relative speed means suppose A and B, A is running in this direction, B is running in this direction. Right? A is going in this direction, B is going in this direction. Now, if we use the concept of relative speed, B will be assumed to come at halt, B is not moving. So, in the opposite direction, speed of A will increase by VA plus VB, means sum of individual speed, right? But in other case, you will see this application in the next slide. But if they are going in the same direction, A is going here, B is also going in this direction, relative velocity of A with respect to B is, first B put B to stop, means B is not moving. A speed will be itself speed minus VB, VA minus VB. I hope this is clear. In circular motion, how we are going to use the concept of relative velocity. VA plus VB when they are going in the opposite direction. VA minus VB is when they are going the same direction. If you are not able to recall it, recall that an example of car overtaking car B and two cars coming in the opposite direction. Same concept. Now, when they will meet for the first time. First case, this is a circle. Here, A and B are moving in the opposite direction. What is the relative velocity of this? Before that, as I've already told you in the concept of relative velocity, assume other to be stopped. Assume other to be stopped. So this question will be similar to that question where two are coming from in the opposite direction to each other, and we assume that B as at stop. Then A speed will be VA plus VB and the distance between them. So time taken for A to go to B will be D by VA plus VB. This is what we have learnt, right? This is a similar concept. A and B are coming from the opposite direction. Now, how much time it will take for them to meet? Time taken by them will be circumference, or means this whole track. This is known as circumference of the circle. So, length of the track means circumference of the track divided by relative velocity. Relative velocity is VA plus VB. I hope this is clear. VA plus VB because they are going in the opposite direction. In the other case, what is it? In the other cases, when they are going in the same direction. When they are going in the same direction, what is happening? So here they are both going in the A is going here, B is going here. Now this is the this is the total circumference. So B is assumed to be stopped. So time taken by A and time taken by A to catch to B is length of track divided by VA minus VB. Minus why? Because if they are going in the same direction, then it is minus. I hope this is clear. Now, what exactly is happening? We have understood what we have done, but what is happening? Meeting for the first time. Meeting for the first time. Now, as I've already told you, we have assumed B is as stop. So B will be sitting here only at this starting point. So B is sitting at the starting point. A, what will A has to do? A will be doing this. A will run from here. He has to cover this whole track to meet B, right? So meeting for the A and B will meet for the first time after this much time. Why? Because B, we are assuming that he has stopped, and we have calculated the relative velocity of A, and using that we have calculated the time for A to meet B for the first time. And this is what we have also done in this case. We have assumed B to stop. So A will has to run the whole track, and since B is sitting at the starting point only, he has to come back to the starting point and then he will meet B for the first time. I hope this concept is clear. Very important. Just note down this. When they are going in the opposite direction, what will the time taken for them to meet for the first time, and when they are going the same direction. Next part. Suppose there are these things. This is a track, and there are not one, not two, but four people are running. A, B, C, and D. A, B, C, and D is the four people who are running a track. A is the fastest of them all. Now, all meeting for the first time means A, B, C, and D has to all be at the same point. Suppose that point could be this. So they are all meeting for the first time at one single point. And what that time will be? For meeting for the first time for all A, B, C, D, what do you have to do? First calculate the time taken that is T1 for A to meet B. How will we calculate? Using the last formula, we know the speed of A, we know the speed of B, then we will calculate the time taken by A to meet B for the first time. Then you will calculate T2, that is A to meet C. Then you will calculate T3, that is A for A to meet D. Once you have calculated T1, T2, T3, that is time taken for A to meet B, C and D, then you find the LCM of those three numbers, and that is the time after which all four of them will meet for the first time, right? This is just a follow up on the last slide. You just first calculate the time taken for A to meet B, use the same concept for A to meet C, for A to meet D, then calculate the LCM, and that is the time LCM of this, and that is the time then they all four will meet for the first time. I hope the circular motion, this thing is clear. Now, first thing, this is A, B, and C are A, B, C, and okay. This is the question. They say time taken for A to complete one round, T2 and T3. Okay. So we have A, B, C, A, B, and C. See, there's a very, I could go into the theory, tell you how these formulas are coming, but for now, just note down these formulas, because the likely of the questions from this concept is low, but still, if you have understood these concepts, you should be able to solve the question they have asked you in the exam. So don't worry, right? So now, A, B, and C are running the track. Now, what do we want to do? We have already seen we want to see A, B, and C meeting for the first time. How can we do that? We can do that by using the concept we have learned in the last slide. But here, now A, B, C are running. We want all of them to meet at the starting point. Not any other point, but the starting point. In the last slide, they are meeting for the first time. that not necessarily they are meeting at this first point or the starting point. They could meet here, they could meet here, they could meet here, anywhere. But we are calculating the time we are meeting for the first time, all four of them together. But here they are all meeting, but only at the starting point. So for all of them to meet at a starting point, you have to calculate. Suppose say A takes suppose 10 minutes to complete the track. B takes 15 minutes to complete the track, and C takes suppose 30 minutes to complete the one round of the track. So to take the LCM of them, so LCM of 10, 15 and 30 will be 30 minutes, right? So 30 minutes is the time after which they all will be at the starting point, and that is where they will meet for the first time. They will meet at the starting point for the first time. At the starting point for the first time. I hope three concepts are clear. Again, a quick recap. When we have learned that when they are going the opposite direction, do VA plus VB. When they are going in the same direction, you have to do VA minus VB. Then we have learned the concept of time taken for A to meet, time taken for A, B, C and D, for all of them to meet for the first time. How did we calculate? T for AB means time taken by A to cover B, time taken by A to cover B, meet C, time taken by A to cover D, and you take the LCM. Now we want all of them to meet at a starting point. Starting point. Starting point means the only difference is we have to take the LCM of time taken by A to complete the track, time taken by B to complete the track, one round of the track, and time taken by C to complete that one round of the track, and that will give you the answer of when they will meet at the starting point again. I hope the circular motion is also done, and that completes our speed and distance video. I understand there was a lot of theory in this video, but I cannot help. You have to learn the theory first, and when you will see the previous year question, you will understand the when you will apply the concepts, you will understand the concepts even more. So if you have understood like even 50-60% of the concepts given in this video, I think that is sufficient. When we will do the PYQs, you will understand these concepts even better. So don't worry. That completes this video. If you have any doubt, you can post them in the comments. And till then, best of luck and see you in the next video.